G'day folks, it's Glenn from Medical Gas Solutions. Just wanting to put together a little video for you guys just to let you know about a product that we have coming in. Medical Gas Solutions, we are a business that services gas equipment. We specialise in medical and veterinary gas equipment. We service and maintain many different sorts of medical gas equipment, but we also do some dental equipment, and I'd like to show you a unit that we have coming in for sale. We have numerous ones of these. This is a digital RA unit, or happy gas unit, or laughing gas to some unit. This is an ideal way to dispense nitrous oxide to a patient. I just wanted to run you through this unit. This particular one is a portable one. It's got some height adjustment on it and some casters. This one wheels around on the floor. You can't see those, but I will send you some photos just for the things that aren't covered in this video. It's difficult to film everything in the one spot on my own here, but basically this unit is an ideal height for a clinician or a dental chair. It has the two lines in the back for the two different gases that many of you will be familiar with. White for oxygen, which is the standard, and obviously the blue for nitrous, also the standard. They connect on the back, and then it has a 240 volt line to power from the wall. This unit, as I say, height adjustable. I might drop it down a little, just trying to get you have a better look at it. It's a digital unit, so we have the on button on the front. It is a 3-color display. It's beeping saying that I'm ready to go. And basically that's come up with green. Green is the total flow or the oxygen flow. Basically in this case the total is oxygen because I've only got oxygen running at the moment. What we have here that I'm adjusting is we have the flow adjustment. So that's the flow in litres or fractions of litres to the patient. So in this case I've got 1.0 litres going to the patient. My percentage is on this side, which I haven't adjusted. By default it's 100. So that's the percentage of oxygen. So 100% oxygen. And over here on the graphical display, this is similar to what the analog displays used to have, the ball going in the glass. Well, this is a digital representation of that. So what we've got is a small oxygen flow and no nitrous flow. We will add nitrous shortly, and you'll see that nitrous is represented by a different colour than the green. So basically by default we have total. That's always telling us, that's the default screen for this, is telling us what the total input to the patient is in percentage and in flow. And then over here under total we have oxygen, and it goes up to oxygen here and tells me that it's 100% at 1 litre, the same as the total. So nitrous should be 0, and it is. There's 0 litres of nitrous coming in. Okay, so let's introduce some nitrous, and the way to do that is to decrease the oxygen percentage. Let's go down to 70, goes in 5-degree percentages. So now we've got, this is percentage oxygen, we're at 70% oxygen. So we must be 30% nitrous to make the 100. So now we've got, by default, we've got a total of 70% oxygen at 1.5 litres. If we press the nitrous button, we've got 0.4 litres. Okay, so we know the total is 1.5, and we've got 0.4 of that as nitrous flowing, 400 mil. And it should be 1.1 for oxygen, and there it is, oxygen 1.1. And then over here what's changed is the nitrous is now flowing, and we have that in blue. So we represent a representation of blue nitrous, and it's flashing because it's just barely enough. So what we'll do is we'll lift that. Let's lift it to 4 litres a minute. Do that in 0.1 or 100 mil increments. Very easy to do. It's a whole touch screen display, easy to wipe, easy to use. Just very durable, just so easy to use. So now we've got the 70%, I didn't change the content, 70% oxygen, 30% nitrous. All I've done is lift the flow. So nitrous is now 1.2 litres, oxygen is 2.8. So 1.2 plus 2.8 equals 4. There's your total, by default total. And over here, we have the flow is lifted. We can actually change the percentage back to 50%. So we've got 50% of each gas, which mathematically is easier on all of us just by intuition. Now we should see a fairly even flow graph, and we do. We see 2 bars of nitrous and 2 bars of oxygen. It's 50-50. I haven't changed the flow. So now it's 50-50, which should be 2 litres of each, because we know the total's 4, and there we go. 2 litres of each gas and a total of 4. So a terrific little unit, easy to use. My hand's probably no bigger than anyone else's, and I can, the unit's only about the same size as my hand. So to give you an idea, it's probably 2/3 of an iPad in size. Very small, light, easy. Has the reservoir bag underneath and the hose, which we'll get to shortly. Has oxygen flush. If we press the flush, the word flush comes, nitrous cuts off, and we get a massive hit of oxygen, and the graph shows oxygen only. So really easy to use the flush, and the bag corresponds with that by filling. You can see the bag is filling very quickly with the flush. So very intuitive. Safeties and alarms has two of those. The big one that we really want to know about is an oxygen failure. So if I just off screen here turn my oxygen flow off. Shortly, we're running at 50% each, I haven't changed. Shortly the oxygen's going to fail, and we'll see what happens there. So trying to bring that over to you so you can see that. Please feel free to zoom this video. I'm not a professional photographer by any means, but there we go. Oxygen failure, so that's come in red. That's the third colour in the screen. It's a 3-colour screen. The red is always alarms. We can't mute that alarm, and we can't stop it. So we have to do something about it. That's the design of it. So I'll reinstate the oxygen, and bang, it clears straight away and goes back to what I set it to. It has a memory to realise what we had set. So okay, so that's the first type of alarm. That's very critical, is the oxygen one. We want the patient always to be getting a minimum 21%. A lot of these devices are built with a minimum of 30 nowadays. So basically we've got both gases. So now we'll simulate a nitrous failure. What happens if the nitrous fails? We've turned the nitrous off now. We're just going to bleed through the rest of it in the system, so it's still feeding off what's in the system. The unit's happy, but shortly what's in the system will run out because the tank is dry, because I've shut it off. But that's showing we're still getting what we need. Patient's getting 50% of each gas at the same flow. But very shortly the nitrous is going to run out. What will happen? We said the alarms are all in red, so we're looking for a red alarm in this case. Nitrous is nearly out. Gone, done, nitrous failure. And then it goes straight to O2. It's telling us that we've got 2 litres of O2 and the graph's telling us O2. So we know the patient's still getting O2 and we can mute the alarm. The reason we can mute this alarm is because nitrous is not critical for living conditions. So we can mute that. And the other reason we can mute the nitrous alarm is because the patient's still getting oxygen. This unit has just gone, right, I can't give you any more nitrous. You wanted 50%, I can't give you any. I'm going to alarm, but I'm going to continue on with what you set in oxygen. And there it is. So it's still getting oxygen. So we can mute that alarm, but when we mute it, the display still says nitrous failure. So let's reinstate the nitrous and see what happens. Bang. By memory, it goes back to 50% of each gas and 4 litres a minute. And the graph is coming back, showing the blue of the nitrous. So really good little unit. Responds very quickly. What happens if you bump or hit the off button? I don't think you'd really bump it because it's as flush as the other buttons, but if you actually purposely turn it off, the patient gets 0 gas from the unit. So no nitrous and no oxygen. But if they are on a circuit and they took a deep breath, because they notice the change or they panic, and this could happen with the unit going, I might add, if they panicked or took a deep inhalation, there's a valve on the side here, the camera might pick it up underneath. That little valve with the holes in it is an entrainment valve. We test that every time we test these units, once or twice a year, depending on the client's needs, minimum once a year for standards. This is a simple mechanical valve that does not care what the digital element is doing. It will open every time to allow the patient to experience room air. So they're going to be able to draw in room air if they took a giant breath in panic or some sort of digital failure, they'll be able to draw in room air. This reservoir bag, we have a safety valve built in underneath to stop them blowing the bag up as well. If the patient did a giant exhalation and somehow it didn't go through your low suction scavenging set up on your chair, dental chair, it would stop the bag blowing.